What's up, betas? Do you want to become Sigma like me and Max? Come join the Maths for Dummies.
So today we're going to be talking about intro for differential calculus. And here we have the graph of a quadratic, and pretty much for differential calculus, at the very core of it, it's about finding the slope of a specific point on this curve. And here, say we're trying to find the curve, the slope of the point at here. The slope will be something like that. And basically, through differential calculus, we can find out the slope of whatever point on this quadratic that we're trying to find. So as for the equation of this curve, it is y equals negative x squared plus 4x plus 2. And I'll talk about this later, but the derivative, basically just the slope of said point, is in the equation of y prime equals negative 2x plus 4. So the first point that we've chosen, it's at 1, 5. So 1 for x and 5 for y. And by subbing in the x point into the equation for the curve, it is, let's write it down here, it will be y equals negative 1 squared plus 4x plus 2. And after all the calculation, it will end up as 5, as the point suggests. But, however, we are trying to find this line, which is the slope at that exact point. And basically how we find that is, after we figure out the equation for the derivative, which we'll get into in our next video, we just plug in the same x coordinate into that equation, and we can find the slope at that point. So now we use this equation. So y prime, which is basically meaning the slope, equal to negative 2, 7, 1, plus 4. So that is negative 2 plus 4, which ends up as 2. So from the resulting number of said equation, we can say that at this point, 1, 5, the slope is 2. So for every x value, it will go up to y value. So here, say we extend this line, the slope, we can see that at 0, it's 0, 3, this point. And then as we go over 1 x value, we also go up 2 y value, which is exactly what the equation suggests with the 2. And now for a different example, say for this point up here, that is 2, 6, also for the same curve. So on that point, the slope would be perfectly flat, since say this marker was the slope. So on this point, the slope is like that, and as it goes up, it gradually plateaus, and then the slope gradually decreases, whereas before it plateaus, the slope would be positive. Now it would be negative. But at the exact midpoint, the slope is actually equal to 0. And how I'm going to prove that is through, once again, subbing in the x value into the equation for the derivative. So y prime equals negative 2, sub in 2 plus 4. So that is equal to negative 4 plus 4. And since they cancel out, the result is 0. So that means the slope is 0, exactly at the point 26. So please hit the subscribe button, like the video, and follow us for more content in the upcoming days for becoming a full-fledged Sigma. So make sure to watch our next video on differential calculus.